Okay, here is the video guide for lesson 5.1.2, focusing on which trig tool we should use and when. We learned in lesson 5.1.1 about how we can use sine, cosine, and tangent. Tangent, what we learned in chapter 4 and introduced sine and cosine yesterday, to solve for these missing sides of right triangles depending on the other sides we were given. And we're going to kind of just use today as a practice day to say, okay, which tool do I use when? And I'm going to, in this video, work a couple of them, and then I'm going to leave some for you to practice and kind of get some hints on the later on ones. And so getting started there, we got to remember, we talk about on lesson 5.1.1 SOHCAHTOA, and that really means sine. You're looking at the opposite side from the angle, so you can see over here opposite of your angle, and the hypotenuse. So sine opposite hypotenuse is SO. We also talk about in 5.1.1 CA, which is cosine. You're looking at this adjacent side and the hypotenuse, and we know adjacent is between the angle and the 90. Between the angle and the 90 is our adjacent side, and the hypotenuse is always across from our 90-degree angle. So that's CA, cosine, adjacent, hypotenuse. Tangent, we have done before. I used to say rise over run, but we're going to keep it with SOHCAHTOA, and TOA is going to mean the opposite side and the adjacent side. So we had that as the rise and the run, but opposite again is across from your angle, adjacent between your angle and your 90, and we're going to say TOA, opposite and adjacent. Okay, and so we're going to look for those certain things when we start answering these problems here. And here I'm going to do A and B, and then I'm going to save slide 3 for you to try them out. And again, always ask questions if you get stuck. So we're looking at these triangles here in A and B, and we're saying which one should we use? Well, I see, okay, I have a 28-degree angle. That's the angle I'm going to use. All right, across from that 28-degree angle over here, that would be like my opposite. So I have an opposite side called x, and I have a hypotenuse, and I know it's the hypotenuse because it's across from my 90 here, and I have a hypotenuse that is 19. So I know I have opposite and hypotenuse. Opposite hypotenuse tells me it's a sine problem. So what I do here is I say, okay, the sine of my angle, let me use my math notes box, the sine of my angle, which is 28, equals that opposite over hypotenuse, and the opposite over hypotenuse is x over 19. And similar to what we did with tangent, I always like to put this over 1 because it helps me cross multiply and solve here. So cross multiplying here, I get 1 times x, that equals x, and I got the sine of 28 equals 19, which is the sine of 28 times 19. Now that is something that we have to do in our calculator, and just like what we did with tangent, we want to make sure we're in degrees because this is 28 degrees. And if I grab my calculator quick, this can be calculated quickly, just like we used to be able to calculate tangent quickly. So I'm doing the sine of 28 times 19, and I'm getting an answer of x equals 8.92. So 8.92. All right, let's take a look at another one, like part B here. Again, the purpose of this is evaluating when do I use which one, cosine, sine, or tangent, SOHCAHTOA. All right, and so we're looking here. I have my angle here, which is 45. I have the opposite side, because across from my angle I have an 8, so I have opposite. And then I have the side that's between the 90 and my angle. The side that's between 90 and my angle, that's the adjacent. So I have opposite, adjacent, and opposite adjacent tells me this is going to be tangent, what we used to call rise over run. And so I can set this up as a tangent problem, and I get the tangent, let me use my math notes again, sorry. The tangent of 45 equals the opposite over the adjacent, the rise over the run, which is 8 over x. And again, I always like to put the tangent over 1 to cross multiply here. I end up getting 1 times 8, that's 8, and that equals tangent of 45 times x, which is the tangent of 45 times x. Now when I get to this point, you always need to divide both sides by tangent to get x by itself. So I'm left with 8 divided by the tangent of 45. And I have x on this side. Again, you can use your calculator here. I do know that the tangent of 45 from early on in chapter 4, the tangent of 45 is equal to 1. So I didn't even really need to use my calculator, but you still could. But that's 8 divided by 1, which would end up giving you 8 equals x. And so those that A and B, and you're going to keep going here in part C, and you're going to try to do D, E, and F. Okay, so it's just some practice here of solving D, E, and F, trying to figure out which one am I using. Where's my reference angle? Do I have opposite hypotenuse? Do I have adjacent hypotenuse, or do I have opposite adjacent? If you have questions, make sure you reach out and ask. Here we're going to look at how we can maybe choose which one we want to use. And so they're saying in this one, Marta forgot her calculator, so she set up her equation as such. Sine of 25, our reference angle, our angle here. And she's using sine because we have the opposite side and the hypotenuse. So she sets it up, sine of her angle, set equal to opposite over hypotenuse, and she cross multiplies and solves here. And we just want to explain each step that she's making. How did she end up getting to this third step here? And then they talk about here in part B that when you calculate it, when you leave it as the sine of 25, that's more accurate than if you round it. So saying you calculate the sine of 25 and then do 29 divided by the decimal you get there, that's a little less accurate because there's going to be some rounding. So they always just say here, this would be an exact answer, but if we use our calculator to solve for x, we might have to round it, which would be not exactly, not exact, but they want us to do that here. They want us to use our calculator here to solve this. Now, this part's interesting here because it brings up how we could maybe use a different one other than sine in this problem. So what they're saying is Ziv is looking at how this is a 25-degree angle and this is a 90-degree angle, and so with our triangle sum theorem, we can find this third angle here, and this third angle would have to be 65. So instead of using the sine of 25, which would be then opposite over hypotenuse, we could use the cosine of 65, this third angle up here, and if we're using the angle up here, then we have the 29 becomes our adjacent because it's between our angle and our 90, and the x is still our hypotenuse. And so we're saying, okay, cosine of 65 equals our adjacent over hypotenuse, and we could try to solve it this way and see if we get the exact same answer as we got when we solved with sine, just depending on which angle we're using. Now here we have trying to do what we just did in part C, okay? We're going to use the sine for 53 degrees because we have opposite and hypotenuse, and then we're going to need to use the cosine of whatever angle you find here using the triangle sum theorem. Okay, because this is going to have to be cosine because then y becomes adjacent because it's between your 90 and your angle, and 5 is still your hypotenuse. And we're going to see, does it work again like it worked in part C, and if you get both your y for cosine, y for sine, then you finish that problem. Here we get to investigate, and this leads into Monday's lesson, I should say, how we can solve for the missing angle. Remember, this is a theta. It represents not a 0, it's a theta. It represents a missing angle. And we can find these thetas by remembering our trig chart, our trig table. And we can say, okay, the slope ratio here would be 9 over 9. That slope ratio, 9 over 9, reduces to 1 over 1. And there's a specific angle that goes with that ratio 1 over 1. Same thing here, where there's a specific angle that goes with the ratio 1 over 5. Now this one for part C, you're going to have to do some investigating on, is there anything previous in this lesson that you may have seen this relationship where the adjacent side is half the length of the hypotenuse? And you're going to have to say, was there any relationship here that can help me solve for what that angle must be? All right, that one's a little tougher. If you get stuck on it, again, always feel free to reach out and ask. And then lastly, we have our learning log. Okay, again, this whole thing is meant to be practicing getting more familiar with SOHCAHTOA and using these trigonomic functions. So please reach out if something was not covered in the video, or if you have questions about something, reach out, email me. I'm happy to make videos on specific slides as always.